talk through the number line method for finding boundary points for absolute value equations or inequalities. We will start with the most basic definition type for absolute value. So this is your basic example right here. Inside the absolute value, it's just a simple variable x, and you would think of this as x equaling positive 5, x equaling negative 5. On a number line representation, the center of this number line would be 0, and you would have two boundary points that are 5 units from the center being 0. Now, compare the absolute value of x to what's happening in the second example. Inside the absolute value bars now, I have x plus 1. So the center of this absolute value is not going to be 0. So notice I've got my not basic example. The coefficient is positive 1 though. So the coefficient, I'm referring to the coefficient on the x term. So the coefficient on the x term is positive 1 in the second example. So the first step is to find the center of your graph. And I'll just use CTR for center. Finding the center of my graph. To find the center of my graph, I take what's inside the absolute value and I set it equal to 0. So here, x is going to equal negative 1. And let me close off this example. And I'm going to use my number line representation. I'll draw my number line over here. So the center of this example is going to be negative 1 as opposed to 0. Notice the subtle difference of what's happening inside the absolute value bars. And now, to find your boundary points by using the number line method, and I'll just use B and P for boundary points, I'm going to add to my center, I'm going to add and subtract to my center. So first off, I'm going to add 5, so the center plus 5, and the center minus 5. Negative 1 plus 5 puts me at 4. Negative 1 plus negative 5 puts me at negative 6. So these are my two boundary points or solutions for this particular equation. And to prove to you that this works, if I were to solve this, and just ignore, I will erase this, so this scratch paper work actually goes with this example. If I were to solve this the way you've been taught to solve absolute value equations, I'm going to arrive at 4, and then I would solve x plus 1 equaling negative 5, and I'm going to arrive at negative 6. So the number line method, you would arrive at the same boundary points, but you're coming at this from the graph as opposed to coming at it from the skill of working with the absolute value equation. And now let's go on and look at the last example, where the coefficient in front of the x term is no longer 1. So I'm assuming that you've got all of these notes written down now, and let's come over here and look at this last example. So my first step is going to be to find the center of my graph. So let's find the center of the graph. So you take what's inside the absolute value bars, and you set that equal to 0. Subtract 7, divide by 2. So my number line is going to look like this. My center is going to be negative 7 over 2. And I actually need some more space, so I'm going to erase all of this and use this to show you what's happening here. All right, so here we go. So here's my number line. Negative 7 over 2 is the center of my number line. Now, to arrive at my boundary points on either side of my center, I am now going to have to add the number that's sitting on the outside, but I need to divide this number by the coefficient on x. So I'm going to add 5 over 2 to the center, and then I'm going to subtract 5 over 2 from the center. Notice that they already have common denominators. So I have negative 7 over 2 plus 5 over 2. That's going to give me negative 2 over 2. And then negative 7 over 2 plus negative 5 over 2 gives me negative 12 over 2. And of course, these are the integers negative 6 and negative 1. So they would represent the solutions for this particular absolute value equation. And so step number 2, to find my boundary points, I'm going to add and subtract the number that's sitting on the outside divided by the coefficient on the x term. Now, to make this a formula analogy, if I have this representing my absolute value equation, and you can match up what I've written in green with the equation that's right here. To find my center, step number 1, to find my center, I take what's inside the absolute value and I set that equal to 0. And that's going to give me an x value of negative b over a. This is negative b over a. To find my boundary points, I'm going to take my center and I'm going to add and subtract c divided by a. And let me come over here. Let's see. Let me give myself a little bit of space. Step number 2, finding my boundary points. I'm going to add and subtract c over a. And I'm going to add and subtract that to my center. So it's my center plus or minus c over a is how I'm going to find my boundary points. Notice that c over a, c over a, negative.